I give you the dimensions on problem 4. All the dimensions on problem 4. Problem 5, you don't have the dimensions, but you're using your grid, and each grid space on the drawings I already gave you is a 1/2 inch, so you can come up with the values for this. On the handout that I gave you, the other handout? Okay, no problem. All right. Okay, now, when you lay these out, it says problem 4, 17 by 11, that's the size paper that you're dealing with. Your measurements are coming from the paper edge. That's important, because if you measure from your title block or the border, it's gonna interfere with your title block. So any measurements that you see here, you're measuring from the paper edge. Okay? You got to position these drawings. You got to measure over and up to locate the front. Top, you locate your perspective, station point, vanishing points, all of that, so that everybody come up with the correct solution. Because when you're dealing with perspectives, if you do it one way, somebody else do it another, you'll get a different picture. I want everybody's pictures to be the same. So you got to follow these measurements and set it up correctly. Okay? All right. Now, we're going to explain each one of these here for you. So, you're going to start off with an orthographic view. So when you're looking at a perspective drawing, going back to your 4 components of a projection, you have the eye of the viewer, the object that you're viewing, your planar projection, and the angle at which you're viewing the object. If I look at it perpendicular, then I get an orthographic projection. But depending on how the eye is viewing the object, I can get a 3-dimensional view of my object. So those are your 4 components of your projection. So now, and then your projectors, of course. Give you an example. When you set up an isometric, a perspective, you can set it up similar, or sketch it similar to the way you did an oblique and an iso. A 1-point perspective is set up similar to an oblique drawing. You have a orthographic view that you're viewing. So this is a 1-point. If I look at the same box and draw an oblique, when I'm dealing with an oblique, lines that go back on my receding edges here, these lines are parallel. They remain parallel to each other. So lines in your orthographic view remains parallel. So this is called a parallel projection. If I'm dealing with a 1-point perspective, then I still start off with an orthographic view, but my lines converge at a vanishing point. And we only have 1 point for a 1-point perspective, so these lines converge at a vanishing point. And when I approximate the depth in this sketch, then I get that sort of a picture. So a 1-point is set up similar to an oblique, where you have an orthographic view facing you. Lines that show depth going back on your receding axis converge at a vanishing point. So it's not called a parallel projection. Your parallel projections are obliques and isometric drawings where these lines remain parallel as they go back along your receding line. So this is more what the human eye sees. The human eye sees something, the further it gets away from you, the smaller it appears. So eventually it vanishes. And so this represents more what the human eye sees. a 1 point, or any perspective, 1 point, 2 point, 3 point. So, we can sketch a perspective. 1 point is simple, 2 point is a little bit more complicated, 3 point is more complicated, or we can draw. Now, on your 1 point perspective, we got it set up because all of these things can change. And so if you change one, then the perspective will look different. So you got to follow the directions so everybody come up with the same perspective. Okay? So, when you're looking at a 1 point, we have a orthographic view. And we'll just use this as our orthographic view. The orthographic view in this case here is sitting on the ground. So we have a ground line. If we set this up, we can project and we look at our top view. And we're going to call our top view, looks like this. And we have a hole running all the way through the top view. So there's my front and top view. The top view can rest on the picture plane or off the picture plane. So here we have a picture plane, or our plane of projection. If I look down on top of this, and my plane of projection, my object is sitting butted up against my plane of projection, then that's what my top view looks like. But I can have my object off of my plane of projection, sitting back from it. Okay? So, this represents the top view of your object. This is your picture plane, plane of projection. Your object is butted up against the plane. If I bring this object in contact with the plane of projection here, then I can trace this object at a 1-to-1 scale on that sheet of paper representing my plane. If I move, so if I wanted this to be a 1-to-1, so when I'm looking at my front view, it's at a 1-to-1 scale because it's sitting on my plane of projection. This represents my plane. If I trace this here, it'll be at a 1-to-1 scale. Okay? If I start my perspective with this off of the plane, then it's not going to be at a 1-to-1 scale. It's going to look smaller relative to how far back from the plane it is. So I want to start off at a 1-to-1 scale. So, this is our plane of projection, our front view. Alright, now, when you're looking at a 1 point perspective, you have a horizon. Your horizon is a line that represents where your object vanishes off into the distance. So when you're looking at a boat on the ocean and so forth, the boat gets further and further away from you. Where it vanishes, that's your horizon. Now, you have a vanishing point. Your vanishing point sits on your horizon, and depending upon where your horizon is at, it will change what you're looking at on your perspective. If I change how I put my top view relative to my picture plane, it will change my perspective. If I move my vanishing point from one side to the other, it will change my perspective. So anything that changes relative to these different components will change your perspective. Again, that's why you got to dimension it and lay it out this way, so everybody should come up with the right solution. Same solution anyway. Okay, so you have a vanishing point. Your vanishing point sits on your horizon. All my lines, now if I were to draw this as an oblique, That's one reason why you're drawing it as an oblique first, so you know approximately what the thing should look like, okay? Now you're drawing it as a perspective and seeing the difference between the two. So that's the oblique. Notice I got receding lines here. Normally these receding lines remain parallel in your oblique, your edge of your object. In this case here, all of these edges converge at my vanishing point. So all my intersections here converge at my vanishing point. Because they're going to become my receding edges as I generate this object. Okay, now you have a station point. Now actually I should have identified the station point first. The station point represents the eye of the viewer. And so you got somebody looking at an object. And typically you identify the station point first because your vanishing point is located directly above or below your station point and it sits on your horizon. So this is my station point. Again, 1 point perspective. So we set up our station point so that our eye of the viewer is such that the cone of projection is approximately 30 degrees that encloses the object when you're viewing the object. So these are my visual rays or my cone of projection, and this is approximately 30 degrees. So if I make them approximately 30 degrees in which the entire object is contained within this cone, as if I'm looking at the object, I get less distortion than if the angle changes. So you know how you can do a camera, take a shot of somebody using a camera lens, and you can get a distorted view of the person? Well, you can do that with perspectives also. At 1 point, 2 point, and 3 point, in the case of a 1 point, this should be approximately 30 degrees to minimize the distortion. So we got the eye of the viewer is your station point. You got your visual rays where you're looking at the object, and this is my visual rays that I'm looking at the object. My station point is directly above, my vanishing point is directly above or below my station point, and it sits on my horizon. So my horizon can be below here, and I can look up under the object with my horizon below the object. You get what's called a bird's eye view. Alright, so basically what happens here is my station point. If my station point moves to here, my vanishing point has to move with it for 1 point. My lines on my angle changes and my perspective change shape. I get a different perspective. If my horizon moves up, my vanishing point has to go up with it and sit on the horizon. That will change the angle of my lines going back, which will change what my perspective looks like. So, if we lay it out, measure from my paper edge and stuff, position the front view correctly, draw it, position the top correctly, and so forth. Measure to locate my station point, vanishing point, and all of that. Then everybody should come up with the same drawing when you get done. So if I'm here, then I get a different perspective of what you guys look like. And if I'm the person, which is the station point, and I come over here, then I get a different perspective of what you look like. If I'm standing up on some chairs and look down, I see more of your head. And I get a different perspective. All right, so now once we've done this, then we have our receding lines going back, and instead of them being parallel, like they are here in my oblique, they're going to converge at my vanishing point. My lines that show depth, to get my depth dimensions, I project my lines from the top view to my station point, and I'm going to get my depth of my object from here. So I just bring these back. Now, this is my picture plane, so this portion of my drop object is true shape, true size. So that's the true size and the shape of that. Anything that goes back from that picture plane is going to be smaller. It gets smaller and smaller. So if I just had a box here and I have a vanishing point there, and I generate another view of that, the way as I go back, the box will get smaller and smaller and smaller until it vanishes off into the distance. Okay, so this will be true shape and true size. This sitting back here won't be the true size. It'll get smaller, this will get smaller, and so forth. Alright, so to get my depth dimension, here's the top edge of my object. Here's the top edge of my object. Again, I've already drawn the oblique. If I drew this and position him here, the front face would sit there. So that would be the top edge of my object. To get how far back, I need to start this back surface here. Then I draw this line here to there, where it crosses your picture plane. Where it crosses your picture plane, you bring it straight down, and where it hits that line here, locates this corner right here. So we call him corner 1. Corner 1 is sitting right there. The front of this is sitting up here. That's the front face. He's going to go away because this front face actually starts back here. So this line is vertical. So lines that are vertical will remain vertical. Lines that are horizontal will remain horizontal. So that will give me a horizontal line coming across here. So that will be parallel. The only lines that won't be parallel are the lines that show depth. This will be a horizontal line. Where it hits here locates that surface back there. So this surface right here is sitting back here is this size. And then this becomes my edge that from this top surface right here to there. So what happens is, as I draw this, typically, knowing that this is not going to be sitting on a picture plane, or not going to be true shape and true size, I would draw this lightly, because I know that I'm not going to see that. And then as I darken in my object, then as I actually produce the edges that I'm going to see and where they're located, I can darken those in. So now this is the back corner of this. So this is my back corner here. We'll just call him 2. Well, to locate this back corner on this top surface, I project this line down where it crosses my picture plane, and it project it down to where it intersects your station point. Where it crosses your picture plane, you bring it straight down again. And where it hits here, it locates the back surface. Now, I might get a little bit of a distorted view of this because I was eyeballing this, my setup and stuff, but that's my back corner. Now this is the outside back corner, and that produces a vertical line going straight down. And so this is my line that's converging right there. And in this case, that's the shape of the object. Because once I locate this point here, this has to hit this line. He has to come over horizontally to maintain that parallelism. He hits here, comes straight down, comes over horizontally. So that one location of this one point here produced this entire surface where it sits back here. Location of this locates that corner there. Here, it comes down vertically. This is a continuation of that, starting here, and so forth. So that's my object there. Now let's say, for instance, we had a hole on this surface right here. Well, let's say we had the same hole starting here. So we had a hole here, and then another hole that started here and went there. Well, the way we want to locate our holes is we want to locate it from the center line of our feature. So if I come here and I project where that hole, the center of that hole is going to start, and it starts right there, where it crosses my picture plane, again, I bring it straight down. And then that will locate the axis of that hole right here. So I know this position. Now, since if I were to draw this hole the correct size here and position him correctly on this front plane, then he would be this size. So I locate the center and take it back. I can take him back to my vanishing point, right there. Where it crosses this line locates the center on that surface. So what I can do here is I can have a light construction line that shows each one of those, shows my axis. Take this quadrant back here. Now when I do this, once I do this and locate that center, I can draw me a horizontal line here. That's where my hole is going to sit. So what I can do here is I can take this quadrant of my circle, take him back, find out where he hits on that right there, take this quadrant of my circle, take him back where he hits, right in there somewhere. So now I know where this is going to hit and that's going to hit. I can take this quadrant of my circle here and take him back. That's going to locate the bottom portion of that. And then I take this one back and that locates the top portion. So what I've done is I've located the quadrant of my circle on this back surface. Then I can take a circle template of that size and create a circle on that size. Oh, okay. And that circle here would be smaller than the circle on the front face, because as it gets further away, it gets smaller and smaller. So my circle back here wouldn't be the same size as the circle here. So that would be my circle on the back face there.
So your circle up there is the true size coming down to the bottom part.
Right, only because this is my plane of projection. I got my front face of this object sitting on my plane, which was this entire front face. So I drew this circle sitting up here as if he would be true size, project back, and as just like this, if I had a circle here and then this converge at a vanishing point, then as I draw this circle back, it'll get smaller and smaller until it vanishes off into the distance. So I'm trying to determine what size circle I would have back on this front face. I know on the front face, because it's sitting on this plane of projection, and I can trace it 1 to 1, so I know this is 1 to 1. Then to locating back here, I locate my center of it, and then from these quadrants here, I just take those back. So I locate this axis here, from the quadrants here, I take those back, and then that locates the point there, and point there, and then that tells me the size of my hole back on that back surface. So that's your 1 point perspective. So each part of your drawing here, drawing number 4 and 5, you have identified ground line, station point, vanishing point, horizon, picture plane. So you lay it out the same correctly based on your dimensions, then everybody should come up with the same solution.
Looks easy.
That is the key.
Now, you should have some light lines and some dark lines. Your top view is dark. Part of your front is going to be light, but as you develop your view, you'll darken it in. So it would be best if you start off with light lines. So what happens is, here, this represents the top view. Here's the top view of the object. This is the head of the person looking at the object at that view, and what he sees or she sees is that picture. So your 1 point perspective becomes part of your orthographic. So I'm looking in this direction. What I see is that right there. Okay, that'll get you started. Now, if you need additional information, read chapter 18 in your text. It goes over a 1 point perspective and 2 point perspective. It covers isometrics, obliques, and perspectives, and to a greater extent than what your other chapters do. But we deal with the easiest of the group, which is your 1 point. And your shape is not all that complicated. I gave you this offset because on your 1 point, you got at least an offset like that. You got a hole in there so that you know if the hole is on the front face here, it won't be the same size as if it's sitting on the back. It's going to be smaller. So I try and give you a little drawing that has a few components that's comparable to what you see on your 1 point. Yes, sir.
So you're wanting us to duplicate this?
I want you to, based on the measurements, draw the front view that you see, draw the top view.
With the planes?
With the planes, I need the planes on there. And then you're going to project down.
But you don't want the dimensional lines?
I don't want the dimension.
Okay.
The dimensions are there so you can draw your views accurately.
All right.
But when you get done, you're going to have what I have up here. You're going to show your light lines for your projections. Don't erase them. Because if I want to trace how you did your drawing, I need those lines on there.
So don't erase.
Don't erase it, but they're light lines. Your top view is dark. When you get done with your perspective, it's dark and so forth. Your ground line, your vanishing point, label those. Sometimes students make a mistake where I tell you where you cross at your picture plane, you come down. Sometimes students crosses the vanishing point or the horizon and then they come down and they wonder why their drawing looks so distorted or so long.
Yeah.
Oh, it's so long, Mr. Rickman.
I didn't do something right.
So this helps you. You cross the picture plane. You bring it straight down to get your depth going back on your receiving line. Okay. So this will get you started. I know you'll have questions on Wednesday, and that'll be fine. We'll do a review on some of this on Wednesday for you.
All right.
All right.
Thank you.
Thank you, sir.